Hello everyone! We continue the series of effects that we can apply to a selected texture or even the entire screen. This time, we will create a simple effect of breaking an image into hexagons, shifting the crop in each of these tiles, and then the final composition of the entire image, or conversely, the decomposition, which can be quite a useful function. So let's get started. This time, I will apply a shader to an image, so instead of the usual color rect, I will create a scene into which I'll drag the mentioned image, which will create a sprite 2D node, like this. So again, right click on scenes, create new scene, and let's call it hex tiles. Okay, and the image is right here. Let's drag it to the scene. It automatically created the sprite 2D node, and in the inspector I will fix the offset, cancel centered, and in transform position let's reset it to 0, 0. Okay, and of course let's not forget about the shader material. Right here, where is it? Here, material, new shader material, click, new shader, hex tiles GD shader, canvas item. Let's just put it to the shaders folder and create, and click again to open in the editor. Okay, and as usual, let me just expand the window. As usual, we'll delete everything that isn't needed, so we are left with just the fragment function. Delete vertex, delete light. Okay, I'll start with uniform parameters, of which we'll have only 2 this time. First, we need to define the number of tiles, specifically the number of tiles along the x-axis, and then the offset, which is the current image shift within the respective tile. Let's write them. Uniform float tiles with a hint range, and let's start with 5 tiles along the x-axis. Hint range would be from 1, we don't want 0 tiles, and we can go up to 50, why not? And the step would be 1, of course, we don't know any fraction tiles. Okay, and the second parameter, uniform float offset, with another hint range, and let's start with 0.1, and this time it would be from 0 to, for example, 10, and step 0.01. Alright, so as is known, for calculations of a hexagonal grid, we'll need the square root of 3, or more precisely, its reciprocal value. To avoid calculating this value for each pixel individually, I will insert it into the code as an constant. This one, const float, and let's call it isqrt3, like inverse square root of 3, and it would be exactly that, 1 divided by square root of 3. Great. Okay, so no further preparatory work is needed. We can proceed with implementing the fragment function. As usual, I'll start by recalculating the aspect ratio based on the image dimensions to ensure the resulting hexagons are not distorted. Vec2 UV is standard UV coordinates, and now the resolution. Vec2 resolution is the inverse value of texture pixel size, and let's do the recalculation. UVX is multiplied by resolution X divided by resolution Y. Cool. Now we need to determine the size of a single cell, which is a simple calculation. We just multiply the UV by the current number of tiles along the x-axis. So the UV would be multiplied by tiles. Cool. Next, is the calculation of the specific hexagon's position, which is exactly the part where we need the constant we created at the beginning. The calculation is based on shifting the UV coordinates to match the hexagonal grid. Let's do it here. Vec2 hex is vec2 UVX times 2 and multiplied by our constant, and UVY plus UVX to make the tiles shifted at the x direction, and again multiplied by our constant. Okay, so for each cell we will define its ID using the floor function, which returns the integer part of a number, making it very suitable for an ID. Additionally, we'll get the local pixel coordinates within the cell using the fract function, which returns the decimal part of a number, so a value in the range of 0 to 1. Let's do it. Vec2 xid would be, as I said, floor of the x, and vec2 hex pos for position is fract of hex. Okay, I think you will see these constructions very often in the algorithms that are based on some kind of tiling. Alright, the next value will be the basis for the vector that shifts the image within the hexagon. We will use modulo 3 to ultimately get 3 different directions. So float, let's call it cell, would be modulo of hex id x plus hex id y, and we are dividing by 3. Okay, to achieve sharp edges for each hexagon, we will use the step function to crop the shifted image so that the result is displayed only within the specific hexagon, like this. And since the hexagon has 6 edges and 2 of them are always parallel, we will need 3 calculations for 3 directions. Float, let's call it edge left, is step of with the edge 1 and the cell value. Similarly, float edge right would damn keyboard, would be step 2 and cell. And finally, this time we will create vector 2 and call it edges, and it would be a result of step with hex position xy and hex position yx inverted. Okay, and the formula for the final shift will look like this. Vec2 shift is hex id plus edge left minus edge right times edges. All these lines simply belong to the algorithm of working with hexagons, so that's why I just use them without any too detailed explanation. But the vector alone is not enough, the shift would be too large. Since we are working with normalized coordinates from 0 to 1, we apply the sine function to the vector, which gives us a much more usable result, and we can actually assign the result to the color value. Color is texture of our texture, and UV coordinates are simply UV increased by the offset and multiplied by the sine value of the photo. Of course. Okay, let's wait for it. Yeah, I think we can already see something here. How can I move it? Can you see the hexagons? They are already there. So we can test the parameters in the inspector. Here we are, shade parameters, so I can increase number of tiles, increasing to 20 for example, and change the offset. And this is exactly the animation we could have observed at the beginning of the video. But it seems that my mouse isn't very sensitive, so I can't demonstrate anything usable right now. So you know what? Let's write a short script that will make this transition much smoother. It will be very quick, so let's do it now. And at the root node I will add a new script and create, and here it is. So first we need this node. I'm holding Control key and releasing the mouse, so it created the onReady declaration, very handy. And now let's define the offset, which is equivalent to the parameter offset in the shader, and it would start at, let's say, 0.2. And we also need a delay, because once we execute the script it would immediately start animating. That's not what we want. We want some kind of delay, 2 seconds, to make sure that we are ready. Okay, and now in the ready function let's set the initial values of the shader. So for example, I think we can do it screen, and now get material, set shader parameter, and it would be tiles. Let's start with 20 tiles, and the second parameter, copy paste, and we will use the offset, and the offset is simply our offset right here. Okay, that's the ready function. And now the process function. So we'll do the usual stuff. In each frame let's decrease the delay of the delta value, and once it drops below 0, if delay is less or equal to 0 and the offset is still a positive number, then let's set the material again, this line, and of course we need to change the offset, so we will decrease it by delta, and I guess it would be too quick, so let's multiply that by 0.1. That should be enough. Let's try to execute the scene. 1, 2, and now it's moving, and we reached the destination. Great. Okay. Thank you for sticking with me until the end. This shader isn't completely perfect, but it can serve as a good foundation for future experiments. If we implement it in the opposite direction, that is, breaking the image into hexagons, and combine it with alpha channel modulation, such an effect might be suitable for the end of a level in our game, or for transitions between different levels. In any case, that would be all for now. So take care, and I'll see you in the next video.